Good morning, everybody. My name's Emma Serkel. I'd like to thank you for choosing to join us today to discuss a very important topic, and that's our electricity bills. Since 2008, businesses on Ergon Energy Tariff 20, General Supply, have warned either a 47.5% or a 78% increase in electricity costs per kilowatt hour of consumption. This increase is a massive surge to business overheads, and we are also looking somewhere in the vicinity of an additional 10 to 15% increase at the end of this financial year. I represent the Regional Development Authority in Far North Queensland and the Torres Strait, who have secured an energy efficiency information grant facilitated by the Federal Department of Industry. Today, your presenter is Kerry White. Kerry is the Regional Area Manager for Tropical Energy Solutions and is based in Cairns. He's a qualified mechanical engineer with over 19 years' experience in building management systems and sustainability design. Tropical Energy Solutions seeks to deliver reliable and affordable energy systems and advice within tropical environments. And just before we kick off, I'd just like to know who's here today? I think we've got Greg.
Yes.
Yes, that's confirmed. And we've got Pam.
Yep, Pam's just come
come in. And are we waiting for anybody else, or?
Is everybody able to hear us okay?
Okay.
All right.
Okay. Yeah, Kerry.
Thanks for that, Emma. Okay, all right, so we'll just kick things off here. Now, what we're talking about is energy and the energy efficiency in the workplace, but there's a lot of principles here that get covered off in other areas of business, so it's not just specifically for the workplace. We have a little screen on our right-hand side. If people want to type in questions as we're going, we're happy to answer them. Otherwise, there'll be a section at the end where people can ask specific questions. Okay, first thing to do is go through a bit of the electricity basics. Everybody's probably familiar with one of these. This is a new electricity bill. We'll break it down a little bit more detail, but the first thing people look at is obviously the amount that's due and when it is due by. We don't really have a lot of information other than that in terms of what this is made up of, what are the main offenders that are actually causing these high costs. These are costs, in this case, $443. These are costs that directly attribute to your bottom line of your business. So any savings that can be made for your power, if you're able to save $100 off your power bill, it's $100 that goes directly back into your bottom line. Just a bit of mathematics. Power is measured in kilowatts, which is the unit of measure. 1 kilowatt is equivalent to 1,000 watts, and 1 kilowatt used over is 1 kilowatt energy. An example used for 24 hours is going to use 2.4 kilowatt hours during that period. A kettle at 2.4 kilowatts used 10 times a day is going to use the same amount. So people look at a kettle as being a high consumer, but also be aware that that one single light operating for a longer period of time is also an equal consumer. Okay, now basically we look at how do we find this data. Now this applies to any electrical appliance, particularly items that are plugged in. You look at what the label rating is on them. So watt equals volts times amps times power factor. But essentially when you look at the label, in this example for the microwave oven, you've got an output of 1200 watts. So this is the actual power that this unit is consuming when it's in high operation mode. So 1200 watts, remember, is 1.2 kilowatts. If that microwave was to operate for an hour, it would use 1.2 kilowatt hours. The only exception to the rule, of course, there's an exception is for air conditioning, where cooling capacity is also measured in watts or kilowatts. And what you're looking for here is the item that says the input current. So max input current is 2.7 kilowatts or 2,750 watts. That's what this unit will consume if it was running at full mode for 1 hour. So that gives you an idea of how much that unit would cost to run. This is the unit of measure that the devices that Ergon are using to measure it. You've basically got two main styles of meters. You've got an analog meter with has the turning wheel, and more prevalent in businesses, and you'll see these units becoming more and more common, is a digital meter. And these are the ones that allow you to have a time of use or a demand or both tariff, and we'll talk about that as well. Okay. Bit of information about Ergon Energy. They are the wholesaler and also the retailer. There are other providers that do the retail side, AGL, Energy Australia, and a few others. They offer quite competitive rates under a contract situation, and they need to be evaluated as a case-by-case basis. The QCA, the Queensland Commission Authority, set the prices for electricity, so it's not actual Ergon. They put a recommendation in, but it's actually the QCA that allow that to happen. So everybody's aware that the new financial year has just brought about some new financial increases for their energy costs. So disappointing, but I guess that's why we stay and see what we think about. Just going through. Okay, so just looking at the power bill, you've got the main amount that's due and the due by date. A couple of things to take into account is the actual information on the meter. We've come across several sites where people are paying for additional power or additional meters where they're not actually on their property or they're not getting the benefit of it. This is important because you don't want to be paying somebody else's power bill, or if you've got multiple accounts that need to be that can be operated as a single account, then you won't be paying those service fees, the additional ones. Also have a look at the issue date and the billing date. In this example, we see 92 days. This is important because sometimes it will be 85 days, sometimes it can be 95 days. So this can artificially make it look like your bill is a little bit higher if it represents a longer period of time. Okay, down here you have some graphical representation in terms of your average daily usage along with your average daily cost. You can see here that July the year previous, the power consumption has gone up, although you've got no hard data to actually match that to a number, but you can see the trends are. You can also see a trend in the middle during the wet season when the air conditioning and refrigeration is working a lot harder, and that's of course when the power costs start going very high. Down here on the left hand side you'll see this is where Ergon will put important notes, so they'll talk about tariffs, they can talk about whether your account was estimated, they can talk a few other things. So these are important little areas to look at on your bill and to understand, and not just that due by and amount due date. This is on the back of the bill. You see here a customer, it's happened over a financial year. There's actually two separate readings based on two separate prices as the price of electricity has gone up. In this case, it's been 16% that it's gone up. So you'll see here they're on tariff 20. They have a previous reading and a current reading, which represents the amount of power that they've used during the period of 87 days. So in this case, they've used 1,128 kilowatts. They were paying 20 cents pre-GST, and what you'll see is that where it steps into the new financial year, they're now paying 23. Down the bottom, you'll see it's on clean energy. This is a service that businesses pay a little bit extra and get their power via a 100% renewable source. This is something that it doesn't necessarily go to your business as a renewable source 100%, but basically means that Ergon, the wholesaler, will generate that power through natural gas or other natural means. Okay, all right, so basically we'll go into the tariff structure. Now the tariff structure is split into two main groups, and we basically have those that are below 100,000 kilowatts a year usage and those that are above. For those that are below, there's three main options for them. Tariff 20, which most small businesses will get put onto by default. And tariff 20 is a straight out consumption-based tariff where you pay, in this example, you pay 25.9 cents per kilowatt that you use any time of the day, and you pay a daily service of $34. Now, this is suitable for most businesses that operate during the day and then go to sleep at night. You'll see here a tariff 22, which is the next one available, and between the periods of 7 a.m. and 9 p.m. at night, you pay slightly higher, you're paying 28 cents per kilowatt, but out of hours, including the weekends, you're paying 20 cents. So this is good where a business has a lot of refrigeration, or an example of a service station where you're actually operating outside those times. Service fees are same, so there's no advantage there. The last one we have for the customers under 100,000 kilowatt use is tariff 41. Tariff 41 is what they call a demand-based tariff. So you get a very attractive 11.3 cents per kilowatt, which is a fantastic rate. But now you get charged a demand fee, if you like, and this one example is 29.56 cents for your kilowatt demand. Now, kilowatt demand is basically your peak demand used during that month. So if your peak demand went up to 20 kilowatts at any one time, you get charged 20 kilowatts times that $29, and that's charged throughout the month. You'll also see that the service fees jumped from $1.50 to 8.8 cents. All right. Now, the other tariffs that you can see in there, these are transitional or obsolete tariffs. And these are, if you're on these tariffs, you're okay to stay with them, but you will get phased out when Ergon decides to cease these tariffs, and you'll be put back onto another generic tariff, like possibly 20 or 22. It's not possible to go onto those transitional tariffs once you're off those. Okay. Okay, just having something to get back. Just type, say something. We should hear you. Everybody able to hear us? Okay. Okay. All right. We'll keep going. If there's a problem, just somebody type into the control panel. Okay, all right, I've got that. Thanks for that, Pam. I'll see if anybody else gives us that feedback as well to what's happening there. Yep, okay. A couple of people that are saying the sound is coming in and out a little bit. I'll just move around if that helps. Okay, hopefully that's better. Is anybody, does that improve things at all? Okay, still echoing. Okay, what we might do, probably because we've got to pick up here and pick up there maybe.
It should be straight through the phone.
Two totally independent ones. Would you like to do a session again? Okay, just a quick question out there. Were people able to hear the information on the tariffs, or would you like me to go through it again? Okay, all right, that's great, guys. Thank you very much. All right, we'll keep going. That's okay. All right. Okay, then we have the tariffs for businesses over 100,000 kilowatts. You'll see here on the left-hand side, you've got tariff 44, tariff 45, and tariff 46. You'll see the consumption rate is, again, that very attractive 11 cents per kilowatt, which is fantastic. And then you get these demand prices. You've gone from $42, $38, and $36 for your demand, and that is based, if you look on the far right-hand side, you'll see that it says demand charge of 30 kilowatts is the minimum that you'll get charged, and then you have a demand charge of 120 kilowatts and 400 kilowatts. So for a customer on Tariff 45, we were looking at a customer this morning who was using 108 kilowatts. That means they're still being charged at 120 kilowatts. So you get charged 120 times $38 on top of your consumption. So it's quite a difficult thing to actually understand what the tariffs are made up of and how it actually works and which is the best one. They're a little bit like phone plans. You'll also notice some significant increases, particularly in this last financial year with the service fees. Tariff 44, $56. Tariff 45, which went up nearly 500% to $184, and Tariff 46, beautiful $537. So that is a fee per day. So yeah, just to have a look at that. And yeah, I think this is probably important to mention at this point. When we do the energy audits part of the kilowatt program, this is the kind of thing that we review and go through. We have a look at your 12 months of data, and if there's a tariff, if you're on the wrong tariff, we found probably over half a dozen people now that have literally would have saved thousands of dollars had they have changed their tariff earlier. We've made recommendations, they've changed it. We've also got the cases where people, if they reduce their demand or their consumption a little bit, it allows them to go on the lower 100,000 kilowatt usage. Okay, so next step we're going to is how do we save power? That's a bit of background there. So how do we save power? There's a lot of noise and a little bit of skepticism, I think, about different energy saving methodologies and how it all works and so forth. So we created a roadmap to allow people to have a bit of a journey of how they would start saving power. So these are 7 basic steps that allow people to go through and have a look at what their business is to actually stop wasting power. So the first thing is tariff optimization. So this is a very low-cost thing. It's something that we do as part of our Level 1 and Level 2 audits. It's built into the $99 or $990 price. And what it is basically a desktop study, has a look at your consumption, has a look at your trends and your patterns, and works out what the best tariff that you're on. Typically people are on ergon tariffs, and we have calculators that can emulate that. The fantastic thing about this is that it's very, very low cost and can lead to quite significant savings. If you've done a tariff review in the past, maybe 1 to 2 years ago, a lot has changed, and it's probably something that you need to regularly have a look at. Okay, next thing you want to have a look at, which we're starting to see, is people that have put solar systems into their businesses, and we're also seeing people do off-grid solar systems for their businesses, or hybrid systems for their businesses. This is allowing people to reduce some of their costs. There is also PPAs, which is a purchase agreement, where people are able to capitalise on some of their power. That's usually in a larger business situation. Step 3 is energy audits. Now, there's a lot of information online. You can do an energy audit yourself. We find typically businesses are quite busy doing business and good at what they're doing, and this is an area that we specialise in. So this is a great opportunity to have people come out, have a look at what your energy consumers are for your business, where the power is going, where the wastage is, and what the recommendations are in terms of technology changes, patterns in the way people operate things, just actually being able to get some confirmation of what the high-cost energy users are and how you can actually do something about that. Okay, next thing is once you actually have those recommendations and the report come through, is you look at your energy conservation initiatives. So you might look at changing your lighting, you might look at changing patterns of how you use your air conditioning. You could look at increasing some tinting by adding some shading to your windows. There's all sorts of options, and we find some very unique opportunities, and each business has its own set little individual characteristics that we pick up in an energy audit. Okay, next thing after that is training and communication. Of course, once you've put all these initiatives in place, it's important that staff and people that work within your business actually understand how this stuff works. There's no point putting energy saving globes in place and then finding that people leave them on all the time because they think they're not using power. This is very important to have information and buy-in from people. It's usually very effective to put somebody in charge of this role as a power-saving exercise, or perhaps have set periods where people are thinking about power saving. Typically, an email out to everybody is not very effective. Okay, measurement and verification. This comes into place when you have disputes with your power retailer, or you actually just want to know where your actual power is going. So this is a process where somebody will come to site with certified equipment, who are going to provide it or have contractors that will provide it, and they can actually measure the amount of electricity that you're going through and at what your patterns are. So this is very helpful if you're on a demand-based tariff and you want to work out how to optimize your costs there. Next thing is ongoing energy management practices. This is things like purchase agreement. So if you start replacing a printer and other bits and pieces, that you actually have a look at the energy efficiency of that item. It's not just the price that you're looking at, it's the overall cost of ownership. Quite often fridges that are cheaper, comparative to other ones, the higher energy ones, long term over the lifespan of 5 to 10 years, they will cost significantly more than the small amount of savings that are made during the capital purchase. Okay, so we just broke it down a little bit into building efficiency. Now for the tropics, it's all about keeping the heat out. For the tablelands, it's a little bit different because you have the humidity, and in some cases we have heating. But we'll talk about this, and you'll be able to apply it where it's applicable. So the first thing you want to be able to do is minimise the external heat loads. So this is your sun coming into your building, which you then have to counter by having your air conditioning work, which you have to pay for. You can do this by maximising your shading. Also consider the effect that happen from thermal mass in terms of the structure of your building. This will help you actually control some of the temperature loads. Minimise internal heat loads, so everything gives off heat, people give off heat, all electronics give off heat, lighting gives off heat, even air conditioning itself is an electronic device and it gives off heat. And maximise natural ventilation. It's free and it's readily available, and if you can utilise that, small savings in your air conditioning, for example, if you're able to reduce your air conditioning by 10% because you're using the doors and the windows being open and the natural ventilation, you'll be able to essentially save 10% in your air conditioning costs, which soon adds up. Okay, we have a unique situation up here in the tropics with the external heat loads. We have in winter, the sun will come up in the northern hemisphere, go from east to west, and you can see here that shading is only on the southern side, but in the wet season, during the summer months, the sun actually rises in the southern hemisphere. So what this creates is a bit of a unique problem where we actually have to shelter our buildings from all four sides. I don't have these same issues down in Victoria and New South Wales. So something to consider. And why it's important, here's a good example using a digital thermometer. One with an office which is in direct sunlight, and they've got internal blinds, they've got books, they've got all sorts of things trying to stop that sun from heating up. The temperature, the one on the left-hand side, the temperature of the glass on the inside, that's where the building will be getting its heat from on the inside, is 62.5 degrees. That's glass that's in direct sunlight. You can see on the digital temperature gauge on the right-hand side that it has a reading of 32 degrees. So just by having your glass in shade, there's a 30-degree difference. Now that is huge in terms of how hard your air conditioning has to work. So these are important factors, and quite often we'll see sites with large glass areas that they could possibly put some shading or tinting on. Okay, so ways of reducing your external heat loads, increasing your shading, vegetation, trees and bushes, shrubs, great opportunities there, awnings, eaves, neighbouring buildings, and screens. These are all things that tend to be in place when we go to site, and quite often people look at upgrades and doing other bits and pieces or new office locations. Insulation options include reflective roof paint, which is very effective. Reflective window coatings, so this can be perforated vinyl, it can be tint. And there's different types of tint in terms of what will actually reflect light and what will reflect light and heat. Window blinds, both internal and external. External are always a lot more efficient than internal blinds, but usually not as controllable or convenient as the internal ones. Foil insulation in the walls and the ceilings. If businesses have had this done, then they get all the benefits in terms of the insulation there. It's normally quite expensive to fit retrospectively, but if people are replacing roofs and other things like that, it's definitely worth considering. Bulk insulation in walls, ceiling and floors. It's important that this has been done and also that it's been maintained in a good condition. If it's been allowed to get wet or it's had things thrown on top of it, it will lose its insulation factors. Okay, thermal mass materials. So high thermal mass materials, we're talking solid objects, so concrete, tilt slabs, stone, bricks, tiles, stuff that will hold its heat for a long time. The advantage of this is maintaining your temperature. So if you have a big variance between your nighttime and your daytime temperatures, particularly if you're in like tableland areas, it carries the cool from the night through to the day. So you're allowed to have a nice comfortable building in the morning without having to use the air conditioning. It works well in shaded locations. It slows down the temperature build-up during the day inside a closed building, so where the warm air is not allowed to come into it. It's not good for seaside locations where you have not a lot of differential between your day and your nighttime temperatures, or locations exposed to direct sunlight. The reason is that the direct sunlight will heat up that thermal mass very quickly. Buildings with high internal heat loads, so buildings that have a lot of printing equipment or office equipment or process equipment or manufacturing equipment or cooking equipment, they produce high internal heat loads, and your high thermal mass buildings aren't going to really benefit you there in that case. They're also not good for maintaining heat radiation after sunset. So if you have a business like a restaurant that operates in the afternoon, it will heat up during the afternoon, and even as the day temperature drops, you'll find that heat will keep on radiating long after the sun has gone down. Low thermal mass materials, so we're talking about timber framed walls, aerated concrete, composites like freezer panel. We're starting to see buildings, particularly roofs, using the composite freezer panel, and it's very, very effective. A little bit more expensive to install. It's very good for heat exposed buildings, for air conditioning buildings, and fast change in temperature within a building. So for example, a modern house these days that is not made out of brick, one that's made out of timber, you'll find that you'll turn the air conditioner on, it will cool down very, very quickly. The downside is that it won't store that cooled charge, and it will change temperature subject to its environment, both internal and external. Natural ventilation, two forms. You've got cross-flow ventilation, where you've got a natural breeze, anabatic breeze, or a breeze that just comes through. Obviously, you need to have an entry and an exit point for that to work really well. And then on the right-hand side, you'll see a convection-style ventilation. You'll recognise this as an anthill. This is how the white ants build their nests, and if you can see there, basically what's happening is the hot air is escaping through the centre and the taller point, and that draws in, like a Venturi effect, draws in cool air from down below. Okay, now if we go on to specifics in terms of air conditioning, there's a lot to take into consideration. The type, age and size are very significant factors in terms of your air conditioning. Modern air conditioning systems can be very efficient. Systems that are 4, 5, 10 years old can be very inefficient, and we still see a lot of systems that are 15 plus years old that have managed to keep alive, but their cost of running is significantly high. You'll see the design and the position is very important of how air conditioning is put in, and it's not just a case of having air conditioning, but it's how it's set up. You'll see in the example on the top left-hand corner where you'll see a series of outdoor units, very architecturally pleasing to the eye in terms of how it is. Unfortunately, the air conditioning unit will blow hot air straight into the next air conditioning unit, which will blow hot air straight into the next air conditioning unit. So it's actually a very, very bad example of how to set up an air conditioning install. And you need to consider things like that, because it's all about being able to get rid of the internal heat. That's what the air conditioning is trying to do. Consider your cooling losses. making sure that you've got well-sealed windows and doors, they automatically close. And natural ventilation comes into effect before you start using your air conditioning. So again, if you can save using your air conditioning by 10% by using natural ventilation, then that's 10% goes straight back onto your bottom line. Usage practices, this is just a common sense approach into if you're not using offices or meeting rooms and so forth, you don't need to have the air conditioning on there, and you have the ability to turn it off to do so. Okay, refrigeration. Refrigeration is an area that we all need, both in our homes and in our businesses. Some businesses have display fridges, some people have walk-in chillers, fridges, freezers. There's all sorts of different things. We see a large variety of sizes, a number of units. There's a lot of people that don't have fridges very well stocked, which means when they open the door, all the cool charge that's inside that fridge, all that cool air, escapes, and the fridge then has to spend the next 10-15 minutes charging that cool air, the new warm air that's gone in there, to back to the set temperature. So a well-stocked fridge that doesn't have a lot of air in it because it's full of food and so forth, that will have a far more efficient and lower cost of use. Location, keeping fridges out of the sunlight, sounds like common sense, but we've seen several locations where people have putting fridges in direct sunlight, or the other thing is they'll put it directly next to a pie warmer or an urn. The age, the condition of the seals, and the maintenance of your fridges and freezers is important. Where the seals aren't sealing, you'll see large areas of ice build up in the right-hand corner here. You'll see the what was once an ice box is now an iceberg. This will make the condenser work significantly harder, and it's not uncommon for a fridge to run 200 up to 300% more expensive because the seals aren't working properly. Okay, lighting opportunities. There's a lot of savings that can happen. We've almost seen the end of incandescent. We have CFL, LED, metal halide, halogen, HID in some cases. So there's lots of different options there. Consider your options for natural light, what your lighting is relative to the job that you're trying to do. If you've got a storeroom that's got massive lighting or an office that doesn't have enough lighting, delamping is a practice in terms of removing some lights while still maintaining the minimum standards. You can see the standard level there of the AS 168. And also switches and timers, sensors, outside nighttime sensors, or movement sensors. You can see this inside offices as well, where people have the lights automatically turn on and turn off as the office is occupied or not occupied. These are fantastic saving opportunities, and often start saving money quite quickly, even after the cost of the actual sensors themselves. Okay, water heating. Water heating is a pain point. There's a lot of different water heating systems in terms of solar versus electric versus gas, and then you've got heat pumps as well. What's important is that again, the type, the size, and the age of the systems that you have, the quality of the insulation, and how much hot water you're actually using. Are you storing too much hot water that you're paying for? Are you losing that heat without needing it? Are you not needing that heat outside of hours, but you're still paying for it? All of these things will help increase your consumption costs, your demand costs, and your overall energy costs. Also, have a look at your unnecessary equipment in an office. It's not often that we actually walk into an office and find there's items that aren't actually being needed that are still plugged in. If the item's plugged in, even on standby, it will consume power. The problem with it consuming power is during that process it also gives off heat. So you're paying for it twice because you're paying for the air conditioning to have to cool it down as well. So remove where possible, remove or at least unplug unnecessary equipment, chargers, printers, and so forth. You'll get the double benefit from the lack of consumption and the savings like heat emissions. Consider also when you're replacing these items what their energy consumption is. Appliances and tools. Here's an example here. You'll see on the top right-hand corner. You've got two items, two toasters. One's a commercial toaster that you'll find in a restaurant lobby area at breakfast time. That'll crank away using 3.6 kilowatts for 4 hours. People drop their little bit of toast in there and away they go. Versus a 1.8 kilowatt toaster on the right-hand side, and that is that's able to provide the same result. People are able to operate at the same level, but significantly less than one on the left-hand side to operate. Location of appliances. Again, we mentioned about having the urns next to fridges. We see quite often in retail shops that sell food and things. They've got heating appliances straight next to cooling appliances, fridges next to cookers and so forth. Look at the operational changes where possible of these things, making sure they can be used on a timer and not consuming power without it. So just to wrap it up, roadmap to energy efficiency. It basically starts with a single step. You may have already put some of the steps in place already. Every journey starts with a single step. And I think probably the biggest advantage that we see is the dollar value, the dollar savings that companies get from having the energy audits. So this is allowing them to get some accurate information in terms of if they're to make subtle changes, what those costs might be and what the return on investment for those costs. Just remember an example that if you were to save $1,000 out of your power bill, that's the same as putting $1,000 profit back into your business. So every journey starts at a single point, and your journey starts today. Thank you for attending the seminar, and I'll pass you back through to Emma to wrap it up.